Hi guys, it's Mrs. Tucker. Today we're going to do a lesson 11-4, linear, quadratic, and exponential models. We're going to compare linear, quadratic, and exponential models, given a set of data, decide which type of function models the data, and write an equation to describe the function. So let's get started. Look at the table and graphs below. The data shows three ways you have learned that variable quantities can be related. The relationships shown are linear, quadratic, and exponential. Okay, take a look at this table. How can you tell from a table that the function is linear? You guys have learned that when you have a constant change in your x's, that correlates to a constant change in your y's. We call that a constant rate of change. So from a table you can tell because of constant rate of change. From a graph you can tell because it graphs as a straight line. Right here, quadratic. From a table, if you have a constant change in your x's, you can tell it's quadratic. You won't have a constant change in your first difference, but you will have a constant change in your second difference. So it's the second difference that you're looking for. And when you graph it, it will graph as a parabola. Yeah, that's kind of a bad looking parabola. It'll graph as a parabola. If from a table you see that you have a constant change in your x's and that you have a constant ratio happening with your y's, then it's exponential. You're multiplying by the same number each time. That's your constant ratio. Therefore, you know it's exponential. From a graph, you see that you've got this kind of curve, and down here at the bottom, it approaches your x-axis or a y of 0, but it never gets there. So that's exponential. In the real world, people often gather data and must decide what kind of relationship, if any, they think best describes their data. All right, graph each data set. Which kind of model best describes the data? All right, they gave us a table. They want us to graph it. Take a look at the graph, and I can tell based on this that it looks like it keeps getting closer and closer to 0. That's an exponential model. I can also tell from the table. All right, on this one, let's graph this and see what we have. You graph those points, it's definitely linear. Another way to decide which kind of relationship, if any, best describes the data set is to use patterns. All right, look for a pattern in each data set to determine which kind of model best describes the data. All right, right here I see a constant change in my x's. They're increasing by 1 each time. Look at this pattern here. It goes from 4 to 68 to 100 to 100 to 68. It looks like right in here I've got a maximum. I see symmetry across that maximum. We definitely have a parabola here, and this is a quadratic model. They're checking out their first difference here. They're not the same, but when you take a look at your second difference, it's constant. So there we've proved that it's quadratic. How about this one? Let's check this one out. Increasing by 1 each time in my x values. What's happening with my y's? I'm multiplying by 1.17 each time. This is a constant ratio, and therefore it's exponential. Okay, after deciding which model best describes your data, you can write a function. Recall the general forms of linear, quadratic, and exponential functions. The basic form for a linear function is y equals mx plus b. Your standard form basic function for quadratics is y equals ax squared plus bx plus c. And your basic equation for exponentials is y equals a times b raised to the x. I'll see you guys in the next video.